Hello, in this video we're going to talk about matrices and linear systems. So let's start off with a definition. We'll start off with the definition of a linear system. So a linear system consists of two or more linear equations. So a linear system consists of two or more linear equations. And again, the term we're defining here is linear system. So let's emphasize that right there. I'd like to take a look at some examples of linear systems. So for example 1, let's solve the system. And the system we want to solve consists of two equations. The first equation is an x plus y equals 5, and the second equation that we will solve is, let's put this in a different color, 2x minus y equals 4. Now if we go back to kind of previous math classes and think about what these equations look like, we could graph them in the xy plane. So the first equation here, x plus y equals 5, that looks like the following equation. It's got a slope of -1, and that looks like that. And we can graph our other equation here, 2x minus y equals 4. And if we put that in y equals mx plus b form, we can get that equation. And the bottom line is we see that there's an intersection point. And our goal in solving the system here is really the following. It's to find values for x and y that satisfy both equations. So we're looking for an xy point that lives on both curves. Okay, so let's do that. Now there's a lot of techniques for solving the system. The technique I'm going to show right here is called elimination. So let's make a note that that's what we're doing. And you've probably seen this in previous math classes, so I won't detail the reasons why we're doing this, but you can see that those y values are opposite in sign. So if we were to add these two equations together, we get an x plus 2x that gives us 3x, and the y plus a -y, those cancel out for us, which is really nice. And on the right hand side we get 9. So that shows us that x equals 3. And if we substitute x equals 3 into either one of our original equations, this one's pretty easy to work with, x plus y equals 5, what we end up getting is y equals 2. So what this means is we get one solution. Our solution here is the xy point, and that equals over 3 up 2. So that's right here on our graph. So this is a case where we get one solution. Okay, and more generally what we'll call this is the unique solution type of outcome. So we get one unique solution. Okay, so that was our first example. Let's do another example, and we'll see some different types of solutions that we can get. So here's another example. We'll look at example 2. So for this one, we want to look at another system of equations. We'll solve the system. And in this scenario, we've got two equations. We've got a negative 2x plus y equals 3. And another equation here, we have a negative 4x plus 2y equals 3. So if we plot these up in our xy coordinate system, we get two equations, and the first one here, let's put that in red, we get negative 2x plus y equals 3. So that looks like the following. So let's label that negative 2x plus y equals 3. And our other curve here, the negative 4 plus 2y equals 3, that's a little bit lower crossing on that y-axis. And again, you could put these in y equals mx plus b form. But the point is here, we've got two parallel lines. Okay, and you might guess here, there's no intersection point, so you might guess that there's going to be no solution for this example. So let's work it out and see what happens. So for this case, let's solve. Let's do our solution here. And in this case, I'm going to use something called substitution. So what I'm going to do is I'm going to solve the first equation for y. So we'll call this equation 1, and we'll call this one down here equation 2. So let's solve equation 1 for y. So here we go. We solve that for y, and we end up with, let's put that in red, y equals 2x plus 3. Okay, and now our game plan is to substitute equation 1 into equation 2. Okay, so let's do that. So equation 2 says negative 4x plus 2y. Now we know what is y. Y, we just found that out. That's 2x plus 3. And continuing on with equation 2, that whole expression equals 2 on the right-hand side. All right, so let's work this out. We get a negative 4x plus 4x plus 6 supposedly equals 2. These two items cancel. 6 equals 2. Oh dear, you know, this cannot happen. So that's not equal. In other words, we ended up with a false statement. There is no solution for the system. And we saw that graphically over here. We saw we had two parallel lines. They never intersect. So this is a case which is what we call the no solution case. Okay, so far we have two examples. In the first example up above, we had one solution or a unique solution. Now in example 2, we have a no solution scenario. And the last example, we're going to get something a little bit different. So let's look at example 3. In example 3, let's solve the system given by 4x minus 2y equals 6 and a 6y minus 3y equals 9. Okay, again, let's plot these up. Take a look what we think might happen, and then we'll verify it algebraically. If we plot these equations, what we discover is that they both lie on the same curve. In other words, 4x minus 2y equals 6 lies on this line right here, and that's the same line as 6 minus 3y equals 9. Okay, so this is really the same line. Okay, they're what we call collinear. All right, let's see what happens algebraically when we try to solve this system. Okay, so our solution. So to solve this, I'd really like to eliminate, I'd really like to use elimination, and I'd really like to eliminate maybe some of these variables. So perhaps our first goal might be to eliminate the variable x. All right, so let's try to do that. Now I can't eliminate them right away, but if I multiply the top equation maybe by a negative 3, so let's multiply equation 1 by a negative 3. and we multiply the bottom equation maybe by positive 2. Let's see what happens here. Okay, so let's see what happens. What we get for the first equation here, we get a negative 12x plus 6y equals negative 18. And on the bottom equation here, we get 12x minus 6y equals 18. And what happens when we add these up? Well, our 12x's, those cancel out, so that gives us a 0. And the 6y's cancel out. And the 18's cancel out. In other words, we have 0 equals 0. This is a situation that's always true. 0 is always equal to 0. In other words, there's no restrictions on x and y. Also